Well, it's still this very nasty noise from here the hoverboard controller. If I turn it off, it's gone. Don't for some hours now, and I have really no idea. So maybe someone can give me a tip. So here, because this is open pull up input, digital input here for the brake. So if I brake, then it will pull to ground, and here I've added a nice switch to still disable here the brake switch. So you see now I'm braking, but I can still disable it so that when I'm going downhill, I can still use the back brake without the electronic shutting of the motor. And so everything okay, but if I now make power to this machine, then really it's 3 volt down to ground, really very nasty. And these this that's because I've already disconnected the serial communication. And so right now you see I also disconnected it's separate battery here for the electronics. And so usually here this goes directly to the main battery. And so when I put this on here, then here's where are we here, the plus and minus cable. And so usually it's here is directly connected. So I already took a completely different battery plus, and the minus here usually is also here. This is a 3-channel current measurement. So it's the only thing that right now that's so to my knowledge between the main battery and well, this controller and my electronics is here the current sensor. I don't really understand this because usually it's used as high side, but I'm using it as load side, so I cannot use the voltage measurement, but I can still use the 3 channels. And so if I disconnect it here, then indeed it helps a bit. So here now, and now I have to pull the plug here. So now it's still there, but not that bad. So that's the first thing I don't understand, why here there is some, you see it's switching between these 3 channels in this chip, and then it makes a comparison between well this pin and the shunt resistors here. And so somehow that's the first thing I don't understand. And here you see, sorry, yeah, but I cannot make it more clearly. Usually here this up to 29 volt go to the first regulator, whereas it here this is can go up to 80 volts. This step down to 11 volts because it needs 11 volt for the traffic car lights. And then these 11 volts go to the standard USB, and the 11 volt are made to 5 volt. And then these 5 volt go here to the Arduino Mini, with this here, well, there's this regulator, and then it's made 3.3 volt. So 3 regulators in series, they end up at 3.3 volt. And still there is this really nasty thing, and it is only the pull up. And okay, there's another connection here, there's a plus to measure the voltage, but here this goes to a 100 kilo ohm potentiometer in the middle. So I don't really think that. And then it's going to here to the I2C AD, and so cannot really imagine that this way the noise goes there. And I already replaced all these analog stuff here with I to C. So now I have the analog here, 4-channel analog here, 16-bit for you see when I would and write. So these end up here. And there's also a bit of noise here in the pull-up digital input. It's not that bad as the, directly on the Arduino Mini pull-up here. Don't understand it. Why? this internal pull-up resistor, I don't know, 100 kilo ohm is somehow I really get this very nasty. Yeah, you see, because I here disconnected. And yeah, if I, you might now say that that's because of, sorry here. It's because of these voltage regulators. So here now, I take directly 3.3 volt here from a notebook, which is also fully on battery. Yeah, so you see still working. And yeah, I will plug in the 3-channel current sensor. Where are we? Here. So it's working again. No noise. And again, here, pure noise. And now here is 3.3 volt for the Arduino Mini are coming here from this regulator here, going directly here into the Arduino Mini, and here we have the pull-up digital input, and still this very nasty. Again, you see if I here now break, then it's pulled down to 0, and so these are not this normal. This is open, so if now it's shortcut, and now it's open switch. And so if I put switch and stick, but it's still working, but the digital input read sometimes fails because of these strange ripples down to 0. And I have no idea. See, I tried here with a capacitor at some points, and so I might try some nanocapacitors, nanofarad, but it shouldn't be. And also don't know why this is making this strange noise, but also other people have bad experiences with this hoverboard controllers making really bad ripples, bad noise on the power line. But I don't know how this ripples then go into here to my electronic circuit, and then end up at the pull-up to make really this very, very nicely. Okay. If someone has any idea what I can do, please give me feedback, and don't complain about all this. This is already some years old, and here you see I really now separated here the controller from here making, so it's already better than it was before, but still have this problem. Okay, bye-bye.